Alright, I want to make a follow-up video for quadratics so I could show you some more examples of how to graph some different stuff, what you're looking for. So we looked at the graph of y equals x squared in the last one. It's really basic. I wanted to look at one that's a little bit more complicated here. For example, y equals x squared minus 5x minus 6. So in the last video we talked about how to find the axis of symmetry, AOS, using the equation x equals minus b over 2a. So notice that in this equation here, a is 1, b is negative 5, c is negative 6. To get these, you're just taking the numbers in front, or the numbers in general if you don't have any x's. So looking at that, you can see where I get those numbers. And you're plugging those in here to your equation minus b over 2a. So a negative 5 would be a positive 5 over 2 times 1 would be 5 halves. 5 over 2. So our axis of symmetry is the equation x equals 5 halves. And then if you want to find the vertex, well, that's a point on the graph. So the minus b over 2a, that's your x value of your vertex. So we already know it's going to have a 5 halves. We don't know what the y value is, though. So if you want to find the y value, well, you have the equation up here. We know that y equals x squared minus 5x minus 6. All you got to do is plug in what x is equal to and try to find the y value. Okay, so 5 halves squared. Well, 5 squared is 25. 2 squared is 4. 5 times 5 is 25 over 2. And noticing here that I have a denominator of 4, I'm going to go ahead and change this to negative 6 to make it negative 24 over 4. That's the same thing as 6. Okay? And I need to change the one in the middle as well. So multiplying this by 2 would give me a 4. If I multiply the top by 2, I get a 50. Okay, 25 minus 24, that would be positive 1/4. And then negative 50 plus 1 would be negative 49/4. Okay, so the y value here is negative 49 over 4. So I found my vertex, which is good. Usually the vertex part is the hardest one, because it can have nasty fractions in there occasionally. So we've done the nasty work, found the vertex. Now what we want to do is we're going to try to factor this. So x squared minus 5x minus 6. If it factors, then we can find the x-intercepts. So we know that x times x gives you x squared. And negative 3 minus 2, that would give you a negative 5, but it doesn't give you a positive 6. So I don't think that's the set of numbers that work here. Let's try 6 and 1. It's about a negative 6 and a positive 1. That would give me a negative 5 in the middle. Negative 6 times positive 1 would give me a negative 6 on the end. So this factors as x minus 6 and x plus 1. Alright, so if I then apply the zero product rule, I know that, if I then plug in 0 for y, that's where how you find your x-intercepts. I can then apply the zero product rule and split this apart, like so, and solve and find that my x-intercepts occur at positive 6 and at negative 1. Okay, so what I've seen here by looking at this is that my vertex is at 5 halves, which is the same thing as 2 1/2. There's my axis of symmetry. I wish I could draw a good straight line, but I'm apparently pretty bad at it. Let me redo my axis here. 1, 2, 3. So this is kind of in the middle there. This is the line x equals 5 halves. Okay. Then at negative 49 over 4, That's way down there. Let me check real quick just to make sure I didn't make a silly mistake somewhere. I don't think I did. So 4 goes into 4 one time, and 4 goes into 9 2 times with 1/4 left over. Negative 49/4 is like negative 12 and 1/4. 6, 7, 8, 9, 10, 11, 12, and 1/4. My vertex is way down there. 1, 2, 3, 4, 5, 6. And then I have an x-intercept at 6, 0. And I have an x-intercept at negative 1, 0. Sorry, you can see my graph here. So this is the point 5, 2. Or 5/2, comma negative 49/4. Here's 6, 0. And negative 1, 0. And based on those 3 points, I can sketch in my graph. Okay. Another useful point on the graph that's usually pretty easy to find is the y-intercept. So if we plug in 0 for y to find the x-intercepts, then to find the y-intercept, you would plug in 0 for x. So if we plug in 0 for x, well, you just get y equals negative 6. So 1, 2, 3, 4, 5, 6. Didn't draw my graph so good. At 0, negative 6. That's going to be my y-intercept. So, technically, let me correct this real quick here. Looks something like this. Okay. So, there's your really good representation of what the graph would look like. Another cool thing you can do is notice that the distance from 0 to 5/2, that's 2.5 units. So if I go 2.5 more units, half, 1, 2, over here at 10/2, which would be 5, I also have a point at where the y value is negative 6. And we can do that by reflecting our graph across the axis of symmetry. Remember that this should fold your graph exactly in half if you fold over the axis of symmetry. It'll fold it exactly on top of each other. So whatever this distance is, you can go that same distance in the other direction and you'll find another point on your graph, which is cool to know. Alright. Let's do one more example here where we have a graph that opens downward. I haven't done one of those yet. Let's say negative x squared minus 6x minus 9. Yeah, that'll be a good one. So notice here, the first thing we want to do is, I guess, find the axis of symmetry again. That's x equals minus b over 2a. In this case, b is negative 6, and a is negative 1. So the axis of symmetry would be at x equals negative 3. Okay. If I go back and I want to find my vertex, well, I do that by plugging in what I found. In the step where I find the axis of symmetry, so I'll plug in negative 3 for all the x's. Well, negative 3 squared would be positive 9, times the negative that I have out front would be a negative 9. Negative 6 and negative 3 would be a positive 18. I still have that minus 9 on the end. So negative 9 and negative 9 is negative 18, plus 18 would be 0. So my vertex is actually at negative 3, 0. Okay? So notice that if I were to go back and I were to factor this, the first thing I would do is I'll pull out a negative from everything. X squared plus 6x plus 9. And then we can factor by guess and check, or we can recognize that this is a perfect square trinomial. It factors as x plus 3 times x plus 3. So notice that if I factor this, both of my x-intercepts occur at -3. In other words, if I were to set this equal to 0 and solve it, I'd get -3 for both of them. They're identical. And that's also my vertex. And then again, one other thing to notice when you're going to graph this is that your graph's going to open downward. Since this number in the very front is negative, your U-shape's going to go down. And then we need at least one more point so that we can reflect it. Let's find the y-intercept real quick. And that's when x is 0. So if you let x be 0, you get -9 for y. So the point 0, -9 is on the graph. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, -9's on there. 1, 2, 3, 4, 5, 6. The point -3, 0 is on there. And that's also where my axis of symmetry goes. So notice that if I go over the 3 units to get to the axis of symmetry, and then I go over 3 more units in the other direction, that at -6, -9, there should be another point on my graph. And then it should open downward and make that U shape. Okay. Alright, so it should look something like that. Okay, so there's another brief introduction into graphing quadratics. You'll see all kinds of stuff that you can do with these. Eventually we'll get to how to complete the square, which actually makes the process of completing the square is confusing for most people. But once we learn how to do it, it means that we can graph this stuff using translations, which is much, much, much easier than going through the process of finding the axis of symmetry and finding the vertex and factoring and all that stuff. So, cool stuff to look forward to. There are a lot of steps here, but you really only need to know, I guess, really 2 formulas. X equals minus b over 2a gives you your axis of symmetry. And then if you wanted to check to see how many x-intercepts you had, you can look at the discriminant, which is b squared minus 4ac. Both of those, though, can be found inside of the quadratic formula. So if you know that one, you've got them all. Alright, so again, here was a review. We talked about finding the y-intercept in this one as well, which I guess could be understood to have been found in the first one. But yeah, so axis, symmetry, vertex, x-intercepts, y-intercepts, and then use the symmetry of the graph to find some more points. And that's quadratics. Alright, so look for a follow-up video in the future. If you have any questions, leave a comment below. And good luck.